Okay, so this is the final video, which covers for example 17 to for example 20, right? Don't do for example 21. Okay, so from here we are going to learn about the volume and surface area of composite solids, right? But before that, let's look at how to convert between meter, right, meter cube to cm cube. Okay, so we know that 1 meter is 100 cm, right? Okay, so 1 meter cube is 100 cm to the power of 3. So 100 times 100 times 100. This is why it is 1 million. Okay, so please write this down somewhere so that you know that it exists. Okay, so for the word example 17, actually we don't really need to use it. What we need to do is, right, on your paper, learn to convert. Okay, so for example, rectangular fish is 120. Now we want the answer to be in meter cube, right? So we convert it to 1.2 meter, 0.4 meter, 0.6 meter. Okay, so volume, length times breadth times height. So we get 1.2 times 0.45 times 0.6, and then we get 0.324 meter cube. Okay, quite easy. Okay, so a cylindrical tin has a volume of 0.0008 meter cube. Radius is 4 cm. So 4 cm is 0.04 meter. Okay, find the height in cm. So if we go back to here, right, you should be able to know that your volume is just your area times height. Base area times height. Base area times height. Okay, so it doesn't matter what is your base area, it's all the same. I'm going to find volume, base area times height. Base area times height. Base area times height. Okay, or even for trapezium, right? Okay, so same thing, base area times height, base area times height, base area times height. Okay, so the base area for cylinder is a circle. Okay, so we just need to find, we know that the radius here is 0.04 meter. Okay, so we find the volume of the, we know the volume of the cylindrical tin is 0.008 meter cube. So this is area of circle. Okay, area of circle. Pi r square. Okay, so pi r square is pi bracket 0.04 bracket square times h equals to 0.0008 divide, right, to find h. We found it in meter because this is meter cube. This is meter cube. Then after that, convert it to cm. Alright, 3 significant figures. Okay. Alright, so these two questions are quite easy. So the next two will be a bit more complicated. Alright, so we say the diagram shows a cross section of a tunnel. Okay, see this is a semicircle on a rectangle. Okay, semicircle rectangle where AB is 4. Okay, BC is 1.8. Okay, so this is your diagram. This is 1.8. This is 4. This is your semicircle. So your radius will be 2. Okay. So they say find the perimeter of the cross section. Now I made a 3D model of this. Okay, I'm going to delete all this. Delete, delete, delete. Okay, and this is the 3D model I made. So if you can see this, right, it is a semicircle combined with a rectangle. So when I combine it, it becomes your tunnel, right? You can hollow it, right? So you can see that this is the air shape inside the tunnel, the shape of the air in the tunnel. Okay, so in order to find the perimeter of the cross section, I know the length of the rectangle. Okay, I just need to know what is this length, right? And this is circumference of circle, right? But half of it because it's a semicircle. So this is here, this blue line. Okay, circumference of semicircle. Alright, which is 2 pi r. Right, so half. Okay, so to find the perimeter, I add here, add here, add here. Okay, so this is the other three lengths. Add them together, I get my answer, 3 significant figures. Because here is written 3 significant figures. Okay? Okay, so for area, generally the same thing. Alright, going back here. Okay, so if I want to show you, okay, I'm going to reverse it so it face up. Okay, I think roughly. Okay, not exact. Okay, but the main thing is I want to show is this. Okay, again, 2D, 2D, 3D, 2D, 3D, 2D, 3D. So we need to find the area of this thing first. Okay, this shape first. Okay, never mind. Okay. Okay, so come back here, we need to find the area of this whole shape here. Okay, so what do? We know the area of a rectangle, right, is 4 times 18, which is this area. Okay, I'm gonna use another color. And the area of this one, right, is area of circle. Again, this area of circle times half. Area of circle pi r square. Okay, so I find and I calculate, I get 13.5. Okay, so now if I want to find the volume, I just need to take this answer, okay, multiply by the, oops, okay, so again, area times height, 2D, 3D, 2D, 3D, 2D, 3D, 2D, 3D. Okay, so I just need to times the length of the tunnel because the tunnel is 130 meter. Okay, so now we want the total area of the lateral face of the tunnel, excluding the face on the ground. Okay, so we just don't want the bottom. Imagine you stand in the tunnel. Okay, you look from here all the way here. So we want to find this curved surface area. Okay, so we need to find which is the same shape as this one, this thing. Okay, so I need to find the length here. I need to find the length here. I need to find the length of this curved semicircle, which we all have, right? So here is the sides. Here is the left side. Here is the right side. Here is the semicircle. Okay, so after you have this length, multiply to find the length, the width of the length of the tunnel. Okay, after you have the measurement of the doorway, okay, times 130 to find the length of the tunnel, and you will have your area. Oh, sorry, this is not cm square, cm cube. This is area, so this one should be meter square. Okay, can? Right. So hopefully this is more clearer, right? hopefully if a question like this ever comes out, you're able to do A, B or C. Okay, so for the last one, I'm going to show you the 3D model for this one. Okay, and it's this. Oops. Okay, this whole thing here. Okay. Right. So again, if I want to find my sorry, trying to move this in the center. Okay, so you want to find my volume, very simple. It is actually just finding the volume of this cylinder and this disc. Okay, so how to find? Very simple, find the area of the base shape, which is the circle, times the height. Then the base shape for the other circle times the height. Okay, so when you go back down here, this is the area of the circle for the small one. Small radius. This one, the radius here is r equals to 0.5. Okay, this one I'm going to use big R equals to 1. So this is the area for this one. Okay, and this one is the area for this whole thing. Okay, including the one in this whole circle here, the big one. Okay, so you times the height here to get this volume, and the other one you times the height here to get this volume. Add them together, convert to 3 significant figure. Okay, this is your answer. So volume should be very easy at this point of time, no matter what they give you. Just find the base area times the length. Okay, total surface area is a bit tricky, okay, but not difficult. Okay, because what I want to show you is this. You have to find this area, right? You have to find the area here, the one around the cylinder, and you find the area here, the one around the cylinder as well. So if you look at this one, then you need to find the area around at the side. Okay, at the side. Okay, I can't write on this one. Okay, you have to find the area of the side of the cylinder, both one. So how do we do it? We find the circumference of this one. Okay, so this one is the circumference of the small of the cylinder. Okay, then this one is the circumference of the big cylinder. Okay, then multiply by the height to get the area. Okay, this is the circumference of disc times height. Okay, times height. Then this is the circumference of bar, okay, times height. Okay, right, times your height here. Okay, then we need to consider how about this area. Okay, how about this area now? Okay, how about this area here, then this area here. Okay, so, and you also have to consider the area at the bottom. Okay, the area at the bottom. Okay, so if I go back to the Tinkercad, okay, so if I look at it this way, you notice that this whole area, instead of finding the area of the ring and the small cylinder on the small circle, the area of the small circle and the ring actually add together to be the area of the big circle, right? So I need to find the bottom area. I need to find the top two, small circle and the ring. So actually I don't need to find the ring and the small circle individually. Right, I can just take the big area below, okay, times 2, because when I add them together from the top, you can see it should equal to the same as a small plus ring. Okay, so from here I just find the area of the big one. Okay, area of circle formula but for the big disk, so it's pi big one squared. Okay, multiply by 2, add them together, solve. Okay, so this part I haven't converted it to 3 significant figures. Okay, so 5.5 times pi equals to 117.278. Okay, round off 17.3 cm3 3SF. Alright, okay, so this concludes the chapter for chapter 11. Right, so please watch the video if you're not sure. Any questions, please ask.